Hey, and welcome to Alchemist.camp, where we learn Elixir and Phoenix by building things. Today we're going to go over one of the most important things for almost any project you can do, which is event tracking. And this video is going to have a few parts. First, I'm going to talk about the basic strategy and considerations that I have in mind. Second, I'm going to go through a few libraries and tools that'll help. And then third, we'll write the code to do it. I want to start by showing a video that I watched last year that I think is really, really good. It's got one of the founders of Reddit, and then also this guy, Emmett Shear, who is the founder and CEO of Twitch. And as you may know, Twitch is not that old of a site, and it's gigantic. I mean, in the non-China market, it's probably the biggest or most used video site, except for YouTube itself. And part of the talk was about analytics specifically. Unfortunately, I can't play the video because then I would get flagged and YouTube would take it down. But it's called How to Build a Product 1, and it's published by Stanford. But basically what he said was you want to start tracking just about as soon as you possibly can, because even if you don't know what to do with your event data, you still may be able to do something really useful with that data in the future. While it's natural to want to log everything you possibly can, there actually is a cost to collecting too much data. It's going to cost in terms of storage space for sure, and it's also going to make it more complicated for you to decide what to do, and it might even slow down your site depending on how you do it. So what he suggested doing was just picking about 5 really important actions that your users take. What are the most important things they can do that you could track? He said for Twitch, it was watching 1 minute of a video, sending a chat to another user, following someone's stream, or buying a premium subscription to someone's stream. And that was basically all they tracked. And he said in the case of Reddit, maybe they would want to track every time a user votes, or comments, or submits a story, or loads a page. And I think for Alchemist Camp, the reasonable things to track would be whenever someone views a page, whenever they subscribe or unsubscribe to premium videos, whenever they refer another user, and when they share a page. There was one other thing that he'd mentioned that was interesting. He basically said you want to use an external platform, something like Mixpanel, but if you're only using Mixpanel, you will eventually run into a problem where it drives you crazy because there'll be something you want to do with your data that they don't support. And I actually experienced that while an employee at a different company. And so I decided to go with a different solution called Keen.io. Keen is somewhat similar to Mixpanel, but it's a bit lower level, and you basically send it information, you send events, and then you can define how you're going to view them and what you're going to do with them. Before I started recording, I instrumented what I'm about to show you and made some requests, and so you can see what we want to send, and that is the full request headers, the user agent, and the user agent is just the string here, but I've also pulled in a library that parses it nicely, and that way we can do things like group all the requests based on which browser engine they have. Then there's some other stuff that I thought would be useful that I'll explain in more detail once we get to the code. Let's look at the libraries we'll be using. First is Keenex. It's basically just a wrapper for Keen.io's API. And you have to do a little bit of setup, add your keys to it, and then it will make the appropriate requests every time you send events. And it's pretty straightforward to use. Second is called UAInspector, and that's what I use to parse the user agent and get something useful out of it. It seems like it's pretty powerful. Like it'll recognize Googlebot, it'll recognize generic crawlers, devices, all that stuff. And the third is Geolix, and that's a geo IP library. It requires a database that you have to download separately, but there is a free one you can use. And there are 3 databases. There's a city, a country, and an enterprise. I've only seen the city to be useful because the city data actually includes country data, and that's it in terms of libraries. So let's check out the code. First thing we're going to do is check out the mix.exs, and you can see I got UAInspector and Geolix, both version 0.16, and then Keenex 1.0.1. So if they have much newer versions when you're watching this, then tread with caution. There may be some stuff that's changed. After adding this and then using MixSteps.get to get these libraries, I can actually increase the font size a little bit more even. Whoa, that's huge. That might work though. So you can see we have UAInspector and Geolix. And both cases, they have to be configured with a database path. And difference is UAInspector will go out and get that database itself. And Geolix, you have to download it and put it somewhere and give it an absolute path. In both cases, you can set things up with environment variables, and that's probably the way to go in production. Then in the Keenex config, you've just got a project ID, a read key, and a write key. And this ID is linked to your project. I would recommend having two separate projects for development and production. In both cases, they'll just be receiving objects, and Keen will figure out the schemas for you. And the read key and write key are pretty much what they sound like, but you don't need to worry about them too much. Keenex handles that abstraction for you as well. And they're really, really long, so I have not really revealed that much at all, even of the development keys. Next thing is, let's look in the big plan here. We have a few kinds of events. And as I said a few moments ago, these events are not too frequent. Even the share event isn't that frequent. And it's pretty straightforward how to do this. Like, we'll just make an API call when the event happens. So that'll be done in our controllers. And the view event is happening every single time we load a page. So the way that I've decided to deal with this is to add a plug into the router. I've made a directory for this, and it is campsite web and then plugs, and I made a file called event.ex. So we'll include that plug here in our browser pipeline. Campsite web.plugs.event. And now let's look at the file itself. In order to function as a plug, this module is going to need two things, an init and a call. And just call it init, and params that we won't use, and I'm going to do nothing at all. And then in the call, we will have some work. It's going to take the con and params, and it has to return the con or else it's not a valid plug. So this is a minimal plug that does absolutely nothing. And let's start by just printing out some information so we can see what's going on. We're going to want those rec headers from the con, so we'll do io.inspect con.rec headers, and we'll also inspect the entire con. This is going to be absolutely ginormous though. And it would also be nice to get the remote IP. So inspect con.remote IP. Right, let's fire that up. With that started, we will check out the server and literally just load any page. So index ought to do it. There we go. We have some things here to work with. So we have the IP address here, and this is just the format that it's logged in, and that's fine. Geolix can use that. And here we have the rec headers. And then above that, we have the entire gigantic con that we're not going to deal with. So let's start by checking out the headers. Headers equals that. And and this looks pretty reasonable, but you can see from the structure here, our headers are tuples, and each tuple is a key value pair. And it's not super easy to work with this. What we're going to do in order to make it easier for us is we'll use enum.into. So we'll just pipe them into enum.into and use an empty object. And now we have a map that we can work with pretty easily. While we're here, let's also check out Geolix. The function is lookup 127.0.0.1. This is not going to be very interesting data because we know nothing about a location from that. But how about if we try 204.321? Now we do have a bunch of data. I'm just going to restrict that to the city because we're actually getting copies of a lot of stuff. All right, so just the city portion of the map gets you the city. The name is Inglewood. Continent, North America. This is something I'm probably going to filter out sometime in the future when I have time to spend on it. Country is the US, and latitude, longitude, and a bunch of these are corrupted because my computer is traditional Chinese characters, and there's a conflict here, but fear not. What's logged on the server will be Unicode and all will be fine. And that's pretty much what we want in both of these. So we'll code them in right here. Headers is what we'll call it, equals enum.into of con.rec headers and an empty map. With those headers, now we can make a data object that we send to Keen.io. And first thing we're going to do is get the assigns out of the con. And that's because the assigns have a lot of useful information in them, both for debugging and also things like user ID. One of the most logical things we're going to want to do once we've got a bunch of data on Keen is look at it on a per user ID basis. We'll add a geo object, basically doing exactly what we just did in the terminal with Geolix. So geolix.lookup con.remoteip, and we'll just take the city out of it because the city data includes country data. And then we've got to get just some basic information about what path and what method the user hit. So first we'll get the host, con.host, and the method, con.method, and an owner. And this owner is actually the PID, so we can't pass a process ID to Keen. What we can do is we can inspect it and it'll just send that number. That's probably not something we're going to use early on, but it could come in useful debugging certain OTP related problems. And path info, which is the first thing we looked at on Keen in this video. Con.path info, port, con.port, and the query string. And then comes the remote IP. And the remote IP is not in the most useful format, at least for a lot of apps. So let's just put this in here as is, and then instead of inspecting the rec headers and the remote IP, which we've already got, we will inspect data. And then we'll reload the page and see what we get. All right, this is pretty useful. This is basically the kind of thing we want to get, but notice that the IP is in this tuple format. Most people and most external applications that you might pass information off to are not going to want to use that. Geolix knows what to do with the tuple, but let's actually report it as a normal looking IP address. So I'm going to copy this down and show you the probably the easiest way to do this, and that would be tuple to list. So now we've got 4 numbers, and then we can join them. enum.join on dots. There we go. Copy this straight into our app. And now let's add the request path. Which is con.requestPath. And it may feel like we're getting just about everything out of this con, but it really is a gigantic object if we did take it all. And this is much less. The rec headers. And that's going to be exactly what we got up here from the headers. And then finally, the user agent. And the user agent is a string, but we're going to use UAInspector parse headers and user agent. And this is going to be the user agent string, and the UAInspector will turn it into a nice looking one. We'll reload the page again. And now we can see a much fuller object. We've still got our assigns, geo, host, method, all that stuff. Then our rec headers are here. It includes the cookie, which does not yet, but will have a unique ID given to each visitor so that we can match them up with their real user ID after they sign up for an account. And then we have the user agent here, which is very clear. And this is another thing that we'll probably be making pie charts out of on Keen so that it's possible to see how many users use which sort of browser. So if somebody says, hey, I'm on a version of Opera from 3 years ago and I'm having a problem, well, that case it's obvious. There aren't that many people. But maybe, say if I didn't use Firefox myself and I saw that 1% of my visitors were on Firefox and there was a problem that was only with Firefox, I might deprioritize it a bit if I didn't love the open web so much, which I do. So I'm going to keep Firefox working nicely on the site in any case. Now let's send all the data off to Keen. So we use Keenex, and all we need to do is add event and name the event. This can be anything we want. I'm going to call these requests and send the data. And the reason I've got IOInspect here is so that we can see Keen's response. So Keen might say this is invalid, or if all went well, it'll say okay, and we'll know that it's been added. Inspect everything else. We have an okay, we do. Okay, created, true. That means we just sent that data to keen.io, and we go back to the browser and look at our stream. We can actually go in here to requests and look at the last request. So rec headers, we can see it was on that page, and timestamp is correct. And you can see the owner is just a PID number. And that is pretty much all the data we want to send. So everything is good, right? No, look at this. This request took almost 3 seconds, which is ridiculous. In fact, I didn't even see it take that long before when I was testing. Okay, so that's like 1 second. And we look at a specific episode. That's 600 milliseconds. Go back to the main page. Okay, well, the first one was anomalous, but still, this should not be 218 milliseconds, not on a local host. Doesn't seem like a big problem, but these slow things will add up. Problem is, we are taking this extra time to look something up in a Geolix database, and we're doing the same deal with the user inspector, the user agent inspector. So what can we do to make this faster? Well, the best thing to do is use some of the functionality built into OTP so that we can spawn a new process and then send the data off in that process while this process just continues on. And none of this data changes anything in the con. We've got a con in and we output a con that's identical. So what we're going to do is we're going to make a new function, and this one will be called send data. And we're going to pass a con to it. And then in the body of this function, we're going to use all of what we had up here and copy it into, or actually just move it into our new function, and do that with holding down Alt and hitting the arrow keys. Visual Studio Code is pretty good about that. All right, Control K, Control X to get rid of the white space. So we have this send headers function that does everything that our previous function was doing except for passing along the con. And we're going to use something called task. Task is basically it's a convenience. It uses OTP features, but instead of having to handle, say, sending the data off to Keen and then having a listener and receiving the response from it and dealing with communication between the spawn process and the original one, Task will do all that for you. It essentially just lets you run some sort of asynchronous process, and it handles the communication for you. So we just give Task a function, and this function is going to be nothing but sending data with the con. And I'm going to put that in parentheses. Now let's take a look at it. Available. Oh, task.start. Yeah, so we got an OK created true, which is very neat because we basically spawned this external process. We did something, we got a response back, we inspected that response, and all of this just came back through. Notice the time it took for this request was, it's trying to do that micro symbol. I'm on a Chinese OS. So yeah, this was super fast. Let's just look at some other routes and make sure it still makes sense. Yep, that's good. And that's also good. Now we don't actually need to be logging all of this to the console, and it probably makes sense for this send data to be a private function. And that's how we'll leave it. All right, so first we made it work, and then we made it fast. I think this is definitely a good first step for event tracking. Obviously, it's a gigantic issue, and there's a lot of stuff to be considered. As I mentioned, you gotta think about how to match up people who've been visiting the site before they sign up with those after they've signed up, because otherwise there'll be no way you can use analytics to improve the number of people that are signing up. But I think this is something I'm pretty satisfied with. Haven't heard the performance of anything, and I'm logging every single view event, and that way, when the time comes in the future, I have this data and I can figure out what sorts of ways to look at it, what sort of dashboards I want to have, and get the information I need to make the site better. If you have any suggestions and think there's more data I should be logging, or something I should be doing a bit differently, by all means, leave a comment, and see you on the new version of alchemist.camp very soon. Till next time, code on.